All right, here we go. Now we're looking at lenses. So this is following along on page 26. Lenses are a little bit more complicated, so I've got a starter diagram we need to discuss to understand this first equation. And then I'm going to erase that and do the ray diagram. So a lot of this stuff is very similar to before. What's new is essentially this part right here and anything down here underlined in black. So I'm going to go ahead and just start by how do you get the focal length of a lens? There's a thing called and these are thin lenses. If you need to do a thick lens, that's a different situation. You could discuss page, I don't know where it is. Page 24 if you need that. All right, in the workbook. Okay, so I should add that in here. This is a thin lens. Okay, so it's a thin lens. Gosh, that's really hard to read. Thin lens, spherical, convex. Now, this is actually a biconvex, meaning both sides of the lens are convex, which is very common. And now, notice we have to figure out these different radii both radii will affect the focal length, as will the index of refraction. Is this made of glass? Is it made of plastic? Is it made of diamond? Is it made of whatever? As well as the medium that it's sitting in, because we know the amount of refraction through a lens will depend on the index of refraction of the material itself, as well as the medium it's sitting in. All right. So what about these radii of curvature? Radius 1 is for a convex lens is on the back side of the lens. Radius 2 is on the front side. Notice what's happening. For lenses, the front and back for the radii and the image are flipped compared to mirrors. The back side of a lens is positive. The back side of a mirror is negative. The back side of a lens is positive. So in this case, I would say R1 is greater than 0. It's on the back side. R2 is less than 0. And notice what that's going to do to the focal point for a convex lens. This is positive minus a negative. This is positive. Assuming your lens is made of glass and the medium is some index less than glass, right? Then we would assume the focal length is positive. I like to remember it this way. If a lens is fat in the middle, it's a positive focal length. What's going to happen? Think of it like a prism. It's going to hit here and bend down. It's going to hit here and bend up. The focal length is positive. And remember, it's going to focus on the back side, which is where we call positive for these. So fat in the middle, positive focal length. Skinny in the middle, diverging, negative focal length. Okay. So this diagram, I need to move it out of the way if I want to draw a ray diagram. Sorry about that. All right, and so let's assume, I think I had some parameters here. What did I say to use? D0 is going to be 65 centimeters. H0 is going to be 30 centimeters. And F is also going to be 30 centimeters. All right, and we're going to try and draw this thing. So let me first start. Let's draw a height of an object 30 centimeters. Okay, there's our object. Is that on there? Yep. Object. All right. Now, 65 centimeters away, 10, 20, 30, 40, 50, 65 is where the mirror is located. Or, sorry, we're doing a lens now. Rather than draw a curved shape, I could just do it like this. Now, if you wanted to see the lens, you could draw a curved little lens in here like this. shade it in. It's fat in the middle, positive focal length. Our focal length is 30 centimeters. So watch this. I'm going to draw the focal length on both sides. 10, and I'm going from this middle dashed line. So 10, 20, 30. There's one focal point. Oh shoot, that's wrong. That's at the 5 mark. So this is 10, 20, 30. That's the focal point. Glad I caught that. 10, 20, 30. There's the focal point. I'll explain that in just a second. Notice for this, the focal point is 30, D0 is 65. So it's 65 to here. So then subtract off 30 and you get what? 35. 10, 20, 35. That's why the focal point's right there. All right. Now, a lot of times I won't even draw this. You can see drawing the gray lens totally just messed me up. So a lot of times I'll just draw the dotted line and I won't even put that lens there. It's easy to screw up. All right. Of course, then you have to understand what shape it is and know that. Let's start by doing the rays. And just so I have room, I wrote the rays in here. So ray 1, this is exactly the same. In parallel, out through F. Ray 2, that's the same. In through the focal point, out parallel. And then ray 3, right through the center of the lens, unrefracted. Obviously, it's going to refract a little here, it'll refract a little bit there. This is actually, the beam gets slightly displaced, but we're going to assume if the lens is thin enough, it just goes straight through. That's why we need a thin lens here. All right. Now, I guess I should mention something. Why am I drawing 2 focal points, and which focal point am I supposed to use? That's a good question. Think about this. Light coming from this side would get focused here, and light coming from this way would get focused there. So that's why there's 2 focal points, because it could be focusing light coming from either direction. And it turns out you're supposed to know, use the right focal point for these. Let me just show you what I mean. In parallel. Ray 1. In parallel. Now think. It's fat in the middle. It should start to focus down and go through this focal point, not through that one. So I'm going to just go like that. Oh, I'm drawing on the ruler, that's funny. Okay. Think about it. This looks kind of like a prism. That should bend this down based on some problem we did in the last chapter. All right, so there's ray 2. Next up, ray 1. In through the focal point and out parallel. Well, look, if I go through the same focal point, we'd expect this ray should get bent down even more. But if I go through this focal point, right, it's going to be coming down. It's going to be exactly the opposite of that one, right? It's coming into the prism. It should be bent to the level. So this is the focal point you're going to use. Now be careful. Some lenses have a negative F. If you had a negative F, you'd have to switch the focal points you use for ray 1 and 2. I'll make a separate video for that. Don't worry. Okay. So we're going in through the focal point. I think a little bit. This looks about right. It's coming in here. It should be bent towards the normal. And then, okay, whatever. I don't know if it's bent towards or away. I don't want to speak. I don't want to screw it up. It's bent that way. How about I say it that way? I don't want to think about normals yet. That's ray 2. And then finally, right through the center. And you see, my diagram's not that great, but that's okay. It's probably this red line is off. That's not very parallel, is it? See this red one? Okay, this is what I mean about checking it more than one. It's still not great. But that's a little better. And I see the image popping up right about here. Somewhere right in there, maybe. Kind of halfway between the two. Somewhere in this mess. So let's just say right here in this middle of this mess. All right. And so out of that, what height do I, so I'm going to get an image distance of 10, 20, 30, 40, 50, I don't know, 53, 52. Let's just say DI equals 53. Is it positive or negative? It's on the back side. Remember, this is the front side. This is the back side. For a lens, the image is positive in back. So this should be a positive image distance. And then the height of the image, I found it to be about, let's just say 24 and a half or something. Let's just say about 25, and these are approximate. What did I say? Something like that. And I checked, I believe this one's pretty close. I think I calculated and I got something like close to 55. But what you could do now is, again, use the R, DO, and HO as givens, crank it out, and see if you get numbers somewhat close to this, okay? Now, is this a real or a virtual image? It is real. The image is positive. You could put a piece of film here and you would be able to expose it. There should be an image there. That's fine. Is it upright or inverted? It's inverted. Okay, it's upside down relative to the object. Relative to the object, it's upside down. Is it enlarged or diminished? I started with 30 centimeters. I ended up with 24. It looks like it's diminished. All right, and then as usual, don't expect your ray diagrams to be perfect, but that's how you do it. At some point, you might be wondering, what happens if you have a negative object? We'll talk about that in lab, but there should be, I'll mention that in lab, or maybe I'll put a link somewhere. Let's call that good.